Welcome, aspirants. Today, we're diving deep into one of the most critical topics for your general science and ability paper, water pollution. And listen, this isn't about just memorizing facts. We're here to build that solid conceptual clarity that's going to help you truly stand out. Okay, so here's our game plan. First, we are going to absolutely nail down what this crisis is all about. Then we'll get into the real science of it, the key pollutants and processes. After that, we'll bring it home and look at the impacts right here in Pakistan. And finally, we'll arm you with the control and prevention strategies you need to know for your exam. All right, let's start at the very beginning. We need to frame this exactly how an examiner thinks. You see, building this strong foundation is absolutely essential if you're aiming for a high-scoring answer. So, when you see a question asking for a definition, what are they really looking for? It's not just dirty water. No way. The key here is specificity. They want to see that you understand it's about contamination with measurable, harmful effects. Let's break down exactly what that means. And here it is. This is what you absolutely need to grasp, that three-pronged impact. When you're writing your answers, you've got to analyze the consequences for the ecosystem, for human health, and for the economy. Using this framework, that's what gives your response some serious analytical depth. Now, pay close attention to this because the distinction between point and non-point sources is a classic exam favorite. You'll see it in MCQs, you'll see it in short answers. Point sources are easy to picture. Think of a single pipe coming from a factory. You can literally point to it. But non-point sources, that's the runoff from thousands of acres of farmland or city streets. It's diffuse, it's spread out, and it is so much harder to manage. Mastering this difference is vital. Okay, so let's get into the science. This is where we see how these basic ideas build into the more complex processes that you're going to be tested on. You've got to understand the how and the what of pollution. Think of this table as your high-yield cheat sheet for revision. So who are the main culprits here? Well, you've got your chemical pollutants, things like nutrients from fertilizers and heavy metals from industry. Then you have the biological threats, like nasty bacteria from untreated sewage. And don't forget the physical stuff, like sediment from construction sites that clouds up the water. Knowing their sources and effects is just non-negotiable. Now, I want you to burn this term into your memory. Eutrophication. It is not just a fancy word. It's a key ecological process that you absolutely have to be able to explain, probably with a diagram in your exam paper. This shows you the devastating chain reaction, and it all starts so simply. You get excess nutrients, maybe from a farm or some sewage, pouring into a lake. This kicks off a huge algal bloom on the surface, which looks like a thick green carpet. That carpet blocks all the sunlight, so the plants underneath die. Then, when the algae itself dies, bacteria start to decompose it, and in the process, they suck up all the oxygen in the water. The result? A dead zone, where fish and other life just can't breathe. Okay, here's another conceptual question favorite, biomagnification. So how does this work? It explains why a top predator, like a big fish or a bird, can have dangerously high levels of toxins like mercury, even if the concentration in the water is super low. Imagine a tiny organism absorbs a little bit of the toxin. Then a small fish eats a bunch of those tiny organisms. Then a bigger fish eats a bunch of those small fish. See? The toxin accumulates, getting more and more concentrated as you move up the food chain. Now let's connect all this science to the real world. This is where you show an examiner that you're not just memorizing theory. You have to ground your answers in the specific challenges we face right here in Pakistan. For a really top-tier analysis, you have to draw a straight line from a specific pollutant to a specific public health crisis. For instance, you can link microbiological contamination from sewage directly to the outbreaks of cholera and typhoid that put so much strain on our healthcare system. Or you can connect industrial pollution to the silent crisis of arsenic poisoning from groundwater, which is a huge issue in parts of Sindh and Punjab. Using a powerful, specific example like the Ravi River is what makes an answer truly stand out. Think about it. Cities like Lahore dump hundreds of millions of gallons of untreated wastewater into the Ravi every single day. So when you state that parts of the river are biologically dead, you're not just throwing out a fact, you're painting a vivid picture of eutrophication and chemical toxicity happening in our own backyard. Okay, understanding the problem is one thing, but examiners really want to see if you can articulate the solutions. So let's shift gears and focus on the strategies, from the big picture policies down to the on-the-ground tech. So these are the macro-level controls, the tools of governance. A great answer will mention the need for strong legal frameworks, but it will also critically point out the challenges in enforcing them. Mentioning the polluter pays principle is also smart. It shows you're thinking about creating economic reasons for industries to clean up their act. This here is the core technological fix for that point source pollution from our cities and factories. So how does it work? Well, primary treatment is pretty simple. It's like a big screen that filters out all the large stuff. Secondary treatment uses good bacteria to eat up the dissolved waste. And tertiary treatment is the advanced, deep cleaning stage that removes specific chemicals and nutrients before the water is finally disinfected and released. And this brings us down to the micro level. These are all about prevention, right at the source. This is how you tackle that tricky non-point pollution we talked about. For farming, it means using fertilizer more intelligently and planting buffer strips of vegetation to catch runoff. For industry, it's about being more efficient, producing less waste, and recycling water. And this is the final thought I really want to leave you with. For your essays, the highest marks always go to those who can elevate the discussion. We have the technology, we know the strategies. The real question is about governance, enforcement, and collective will. Moving your analysis beyond just the technical fixes to talk about these deeper issues of implementation, that is what separates a good answer from a truly great one.